Let's talk about consensus algorithms. Whenever we are working in decentralized applications or distributed systems where we are storing our data, maybe text file, image file, audio file, video file, stream of data in the distributed machine on different nodes. So at that times, we are ensure that data consistency. So consensus algorithm help us to make the data consistency happen in the distributed system. Okay, so maybe this is the multiples database data storage server, data storage server one, data storage server, 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 data storage server. And now from this data storage server, our intention is that whatever the informations are data stored here, that would be available for every uh, data center. Okay, so that customers of the nearest location try to access and they get the same value. So this is the one of the technique or approach. The consensus algorithm ensure that data are properly are synced. So some mutual understanding between the nodes decide, hey, I am going to become a ensure that I am going to sync data from the multiple nodes. And similarly, multiple nodes also think same, reach on the particular points where they are ensuring that they are replicated data in the different data centers. So in this, you can say consensus algorithm is a kind of a procedure, or you can say a protocol that enables a group of nodes in the distributed system to agree on a single value or a state of a system. Okay, so we have to ensure that whatever the exact state of the system, whatever the system of exact x, this would be agree of every element. That is, this is the value is latest and updated for every node. That is the name. Okay, whatever the number of nodes, each nodes are agree that, hey, this is the state of the system is the right and updated and correct value. Even in the presence of failure, network partition happen, some concurrent update happen. Whatever that happen, because the distributed system, multiples our data storage server, which are storing data, and multiples request, concurrent request can be provide some read write update operation on the any state. So overall, what is the system state would be? Somehow we have to everyone must be agree that this is the server which have a exact and right updated value. Let's everyone agree that yeah, this is the overall system state would be. That means this is the value of the system is current and updated, and that should be for every node. Even let's see here some fault here, some new request update come. Okay, and somehow they are going to shut down, restart network, something problem happen. So when still once they receive, even they are not able to transfer the request to the other node for replicate. They have a concept where once they receive, they have a stored data in the event store, and even whenever data system up from the event store, they restore our state and again going to replicate to the everyone. So that objective is that whatever the systems accurate, correct, right value, every nodes are agree and everyone can update its local storage as the same as a mutual understanding of the current state of the system. So these algorithms, a procedure, a technique help us that all the node in the system have a consistent view of the system state. So from the customer perspective, from the system designer perspective, it's okay. On the overall our globe, we have lots of data storage servers, data storage machines. And from the customer perspective, customer from this location are try to access the system, or from this location try to access the system. System state or behavior or response would be the same for the same request. If the particular customers require a particular resources, these resources are accessed from the across geolocation, always be the consistent view. Now, same data, accurate data, and latest data must be same. So this algorithm ensure that whatever the our distributed system, whatever number of nodes are associated in this our system, each and every node must have a consistent provide the view to the every customers, and which is essential for maintaining the integrity and the reliability of system. So you can say overall this consensus algorithm ensure that our customers, our data, whatever the data, our data storage server are maintaining, that's maintain the all the integrity, and in this way we are offer a reliable system to the customer. Customers are relying on my technology, on my storage server, because we always ensuring that whatever our system receive any data from the customer, we are able to manage, store, even in a case of fault happen, in a case of network partition happen, even in the concurrent update happen, all the scenario, we, our consensus algorithm ensure that each and every nodes are agree at the latest state of the system, and they every nodes are replicated this data on the uh, our every nodes, and every node provide the same view to the every customers. So these are the, you can say, very common consensus algorithms, and lots of use case scenarios we will talk. And the algorithm have lots of types, lots of different types of consensus algorithm. We cannot cover each and every, but whenever you are going to design the distributed systems and where all the distributed node, you want to ensure that every nodes are give the latest current updated value to the every customer. This consensus algorithm help us, and that's way we can ensuring that our system very reliable and maintain the integrity of the systems. So generally, the applications, if you look kind of scenario, might be this consensus algorithm can be applied in the centralized systems, or maybe decentralized, or some fault tolerance scenario as well as. Okay, so the centralized consensus algorithm, these algorithm rely on the single node called the leader or coordinator node to manage consensus process. That means whatever the our distributed node data storage location server we have, between that we have select one single node as a coordinator node. That coordinate ensure that the whatever the data storage they have, every distributed node must get the those updated latest value. So this single node is responsible to ensure that in the distributed systems, all the nodes have a same copy. If somehow this single node is going to down, going to crash, going to problem as a coordinator node or as a leader node. So all other node also known as a follower node. So these follower nodes also capable to select one leader again. So let's be selected this leader node. Now this leader node responsibility, this play role as a leader or coordinator node, and they are going to ensure that in our cluster, whatever the data storage servers have, they have a sync and updated and give the consistency. And one of the scenario where the decentralized applications where also we are going to apply the consensus algorithm. These algorithm not rely on the single node or instead the distributed approach to achieve the consensus. Here, every node, every data storage server in the particular clusters, whatever the cluster we have, every data storage server are responsible to get the read request or write request. But this is the responsibility of this one. They are going to ensure that all other nodes in the my cluster must be sync. Similarly, let's see here. This is also receive the request and read and write request, and he this is once updated, it's responsibility they can update each and every node in the cluster. So here you can say not only one node or data storage or server are responsible to ensuring that the same data are available, latest data is available to everyone, but every nodes in these decentralized applications are responsible. In the centralized application, the leader node or coordinator node is responsible to managing the consensus process. But in the case of decentralized applications, every nodes considered as a coordinator and play a role of the start initiating consensus process. Consensus process, that means ki every nodes are agree that this is the system state, that is the current value, correct value, let's sync to everyone. And sometimes you can also use this consensus algorithm in the fault tolerance scenario, binetized fault tolerance scenario. These algorithm also designed to tolerate the arbitrary failure or any malicious nodes. So someone malicious node, someone attack, something problem happen. If while the monitoring or system we have identified, hey, this node now is not up to our security guidelines, some failure happens, something unwanted happen in system. Still, on those scenario, those these consensus algorithm ensure that the recovery happens. So these consensus algorithms can be, you can say, work in the scenario where distributed systems and maybe centralized application or decentralized applications. This consensus algorithm ensure that every nodes are come on the single value or single states of the applications. So whenever you talk about this consensus algorithms, we have to also need understand the basic terminology like agreement. All the nodes agree on the single value or state of the system. Overall, the systems from the customer perspective, individual customer perspective, is the only one system. Internally, might be we have a lots of distributed storage location. We are managing, handling high volume data, maintaining high availability, maintaining the scalability. But customer point of view, they are accessing the only one system. Okay, and they are considering, let's see, I have access particular time is the value x, so next time I am going to accessing this value should be the x, not should be going to sometime x, sometime y, sometime z. So this is the data consistency issue. So he this agreement that ensuring that all and every nodes are agree on the single value, so that the single value are synced to the every places. Second point about this validity. Agreed upon the value is a value, not corrupted, not tampered with. To ensure that everyone going to agree on the latest, updated, and right value. We have to validate this validity. We are not saying this one server is a have an older copy and everyone going to agree on the older copy of the data, no. So the times at the what at the which times the particular nodes receive the update information or new informations. So here time factor also very important. In the case of concurrency, concurrent requests are coming here. Okay, so still we have to decide which is the latest value. So somehow we have to ensure that the all the nodes are going to agree on the specific value. That value must be valid, must be correct, must be updated, and must be latest. And this termination, this algorithms terminate the finite number of stated. So we have to ensure that any algorithm we have decided, we have to finite number of steps through which we can complete this consensus process. And overall, the system, whatever we are going to ensure that this algorithm ensure that our systems maintain its integrity with respect to upon the value upon the data uh, as a consistent view across the different location, different customer, different point of view. This algorithm ensure that agreed on the value that is consistent with the system rules and constraints. In the this integrity is the very key factor about in the consensus algorithm, because our objective is that whatever the system we deliver to the customer, that's give the consistency. Generally, this have some steps how it's work, you can say. So this any nodes are going to start proposal. A node propose value or state change. Hey, these are the our clusters, and this cluster have a multiple nodes. So anyone receive the write request or update request, they are going to propose that, hey, this is the my state change to the everyone. And now consensus algorithm decide everyone now going to agree, yeah, it is a right state, correct state of my systems or what. The first proposal is started by one node, and then voting is started. The votes are nodes vote the proposal. So every nodes are going to start proposal. Yeah, it is a your latest or your latest or your latest or your latest or some more latest come. So on the basis of vote, then every between the every node, your consensus going to establish. The algorithm determine whether the proposal is accepted or rejected based on the vote. Okay, and during this scenario, if everyone, whatever the number algorithm decide consensus algorithm. Hey, this is the proposal which are submitted, which are initiated by the one node, that is agreed, acceptable, or rejectable. Both can be happen. If acceptable, if proposal is accepted, then the node going to the commit new state, and this new state are updated by the every node in the systems. Okay. So these are the first proposal, then voting, that consensus, and after consensus is accepted or rejected, and after that system state going to change. So please ensure that here any nodes are going to change his state after updating, informing everyone that, hey, this is the application state I am going to change. Are you everyone agree? Everyone agree? That since I'm committing my data, everyone also can commit the same state. That means everyone now have a same state of the data. So proposal, voting, consensus, and after that we are going to change the system state. So this is the algorithm how our consensus algorithm ensure that data integrity in the systems. So for this, lots of algorithm, more than 10 advanced algorithms for this consensus algorithm. Surely, I'm not going to talk in detail, but whenever you in the situation you are going to implement this consensus algorithm, as per your use case, you can take different algorithm. Maybe Box OS or Raft or PBFT or blockchain, lots of kind of algorithm available. These have a different. Generally, all these algorithm based on the leader follower kind of algorithm. So this is a leader based consensus algorithm that uses the voting mechanics to achieve this consensus. Similarly, Raft is also leader-based consensus algorithm that is a combination of voting and heartbeat to achieve the consensus. So this is a decentralized. These are the formats. Leader-based means for the centralized application. Means one is the leader, all others are follower. Sometimes no, multi-master you can say multiple, all can be leader. So in the distributed application, you can say, hey, consensus algorithm can be tolerated with the band attribute features. And similarly, on the blockchain, also this is a decentralized consensus algorithm that ensure that whatever the changes happen in the one node, that can be share with every node so that everyone can be agree and that those changes going to the commune. So blockchain is nowadays is a very good example in the decentralized consensus algorithms. And nowadays, due to the distributed, lots of applications currently running on a distributed node. So these algorithms, consensus algorithm, play a very crucial role to maintain the uh, data integrity and consistency of the system. And lots of scenario applications use cases where you can think this consensus algorithm play a big role. Maybe you talked about the distributed databases or cryptocurrency, which you talk about blockchain, or maybe smart contracts, maybe distributed file storage, maybe distributed block storage, or all the cloud computing, or maybe your IoT applications, maybe financial system, maybe healthcare system. Lots of all the where centralized or decentralized, where you are going to managing the data or your information on the multiple node, multiple server. So you must need ensure that data consistency. So data consistency are actually implemented using the consensus algorithms. This algorithm play a very critical role for the system consistency point of view. Lots of technology nowadays available which already implemented this consensus algorithm. Just we as a system design engineer, our not responsibility, we are going to start developing this algorithm from scratch. Let's use the existing technology. Existing technology help us to meet the objective of my system. Even the data are stored, information is stored in the distributed node, still we are able to provide the consistent view to the customer, to the system, to the third party. Very popular technology for this consensus algorithm is the Apache ZooKeeper. It's the distributed, you can say, coordination service that implemented on the basis of consensus algorithm. And nowadays, you can go to the Kafka and other applications. They are many, lots of real applications are using this Zookeeper to maintain the consensus between the distributed node. Or you can say etcd is the also distributed key value store that provide the consensus algorithm. Or you can say Consul is a service discovery and configuration tool that's also provide the consensus algorithm. Even Hyperledger Fabric is a blockchain platform that provide the consensus algorithm. For this algorithm, Rush is also one of the programming language or library, a framework that's also allow us to build the consensus algorithms. So this is the limit, but you can just explore on Google. Lots of tool, technology, framework, language available for the consensus algorithm. In the case of your data storage in the multiple server, multiple location. I want to ensure that our system maintain the data consistency. So these consensus algorithm play a very crucial role for your systems. So that is the about your consensus algorithm. So overall, you can say this is a very fundamental concept in the distributed system, because whenever you are talking distributed system, that means you are working the lots of server. Generally, servers have a some data or some information is stored. So whatever the information you are storing, you are ensure that the data must be consistent. So this enabling loads agree to a single step. That means this algorithm ensure that whatever the data is stored by the any node, that are the correct, right, updated, and latest copy. With the increasing adoption of a distributed system and a blockchain technology, the importance of consensus algorithms will only continue to grow. So nowadays, lots of cryptography, blockchain technology going down. Blockchain is a very distributed system where there is no any centralized governance, but still in the scenario you must want to data consistency. So whatever the one in the blockchain, whatever the one nodes data transaction detail get changes, they are going to replicate everywhere, so that every nodes are going to aware, hey, this change is going to happen, this is the right or not right. They are going to apply proposal, they are going to apply the voting, they are going to consensus algorithm, and then finally decided, hey, in the blockchain, in the distribution, hey, this is the right data, this is the correct value, this is the system updated value, valid value, then they are going to the commit. So even the field continue to evolve in the distributed system. So we can expect seeing a new concepts, algorithm, and technique emerge to addressing the challenges of scalability, security, and performance. So you can say lots of improvements, lots of use case, lots of scenario where you can think this consensus algorithms are very help. The overall objective of this algorithm is that in the distributed system, all the nodes, whatever the number of nodes, whatever the values, the latest value are for the system, that is really, if everyone is able to validate, first proposal, validation from everyone, every year, this is the right value, then they are going to the. So in this way, you can say at least we are ensuring that our system view is always with the consistent. Due to that, blockchain technology are nowadays very you can say uh, secure kind of a data integrity point of view or consistency point of view. This consensus algorithm ensure that our data integrity and system consistency in the distributed, decentralized, or even centralized coordination server. Okay, so these help us. This consensus algorithm help us ensure that whatever the distributed system we deliver to the customer rely on the our system as very highly maintain the data integrity and the system consistency, the consistent view for all the server, all the customers, all the users. So that's for the day, and hope this information is helpful for you. Thank you.